All right, so hi mathematicians, back to our ratio tables. So this question is asking us one set of baseballs costs $27. How much would two sets cost? So the question is, how much would two sets of 27 or 2 times 27? Remember that ratio. So in a ratio table, what we do is we write the two things that we're comparing. In this case, we're comparing the sets of baseballs and the cost. So one set of baseballs, as it says up here in the story problem, costs $27. So why we write this as a table? It keeps our thoughts organized, and it allows us to move back and forth within the ratio table to try and figure out the product or the quotient, the multiplication answer or the division answer, um, more easily and in a more organized fashion. So we're going to be multiplying big numbers, but using a ratio table. And most of the time, my students love this strategy when we're doing multiplication strategies. So one set of baseballs costs $27. What does two sets cost? When we write the expression, it comes out as 2 times 27. Now, when we're doing the ratio table, we go from 1 to 2. So we're multiplying the 1 by 2. Now we're up to 2. So on the bottom, we do the exact same ratio. So we're going to multiply by 2. So just like with the recipe, if we're doubling the recipe, we're doubling the ingredients, okay? But in this case, we're doubling the sets of baseballs. So we're doubling the cost. So we're doubling the cost. 27 times 2 is 54. So two sets of baseballs cost $54 times 2 times 2. Okay, so let's go to the next one. Now up here it says how much would 4 sets cost? So we're going from 2 sets to 4 sets. The expression is 4 times 27. So same with the previous ratio. We're multiplying by 2 or just doubling. So we're going from 2 to 4. So times 2 times 2. Whatever we do to the bottom or whatever we do to the top, we have to do to the bottom. So with that same ratio, thinking about the same thing, we're going to multiply or double 54. So 54 times 2 is 108. So one set costs $27, two sets cost $54, 4 sets cost $108. We're doubling, doubling, and doubling. What do you know? The next question is what would 8 sets cost? And the expression is 8 times 27. So we're doubling the 2 to the 4, 4 to the 8. Let's see here. So now we're to the 8. And we're going to show the same ratio. This is what we do in class as well. I like to see your work showing me what the ratio is that you're doing for both sets on the top and the bottom. So the same thing, we're just doubling from the 4 to the 8. So 4 times 2 is 8. And then we're going to do the same thing on the bottom. 108 times 2 is 216. We're doubling 108. Now we're to 216. So 8 times 27 is 216. But now we're up to 10. So we're not doubling again. We're going up by 2. So we're going from 8 to 10. So how could we figure that out? Well, there's several ways that we could do that. Now that we have all of this information in our ratios, in our ratio table, to figure out 10 times 27, which is our expression, a lot of you probably know that off the top of your head. You're thinking, 27 times 10. I think I know that, Mr. Mack, because I know 27 times 1 is 27. That's right here. And then if I just multiply that by 10, 27 times 10, or put the 0 on the end, I think I can get that. But what this is showing us is a different way to do it. It's saying if it's not that easy just to figure out 10, because that is kind of one of those that you can easily figure out, but what if it was like 12? Well, they're saying you can add 2 of your numbers in your ratio table. So we have 8 and 2. 8 plus 2 is 10, right? So we added this number 8 and this number 2, which is 10. So in a ratio, you would do the exact same thing on the bottom number. You would add 216 and 54. Let's see if it circles it. It does. Oh, it went back. Okay. So it did 216 and 54 is 270. You guys see that? So what it did was it took this 8 and this 2, which both equal 10. That was my top ratio, the sets of baseballs. And then whatever number is below it, if you have the correct number below it, then when you add the 54, which is 2 sets of baseballs, and 216, which is 8 sets of baseballs, 216 plus 54 gives you 270. And I know that's right because 27 times 10 is 270. So, but that's a great way to think about it when we're getting into bigger numbers that we are having a little more a little difference. So what this is showing you with the ratio. So, but what they did here was they added 2 to make it 10, right? 8 plus 2 is 10. We're not adding 2 to the bottom, just 2, because that's not how much the set of baseballs cost. We're adding 2 sets of 27 baseballs because really we're adding 54. So we're not just adding 2, we're adding the cost of the baseballs. So one set of baseball costs $27, but we're adding 2 sets, which is $54. So that's where the ratios get a little tricky because you're thinking about it in terms of the amount of sets of baseballs up top. And on the bottom, you're thinking about it in terms of cost per set of baseballs. So that's why the number is going to be different, but the ratio stays the same. A little tricky, but we'll get the hang of it. So now it's asking, well, how much will 9 baseballs cost? So we're going to go back from 10, and our expression becomes 9 times 27. Well, we're at 10. We know that's 270. What do I have in my ratio table that could help me? Oh, I have an 8 here, and I have a 1 here. 8 plus 1 is 9. And I have a 27 in my 1 column. And I have a 216 in my 8 column. If I added 216 plus 27, that could give me my 9. Let's see what they decide to do here. So they took the 10 and subtracted the 1. Interesting. So they minus 1. I don't know if I would have done that, but it's something that you could do. So it's the same strategy as adding, but you're subtracting. So 270 is 10, and you're taking away this 1 column, which is 27, right? So Mr. Mack said, I would add the 8 plus 1 to give me 9. They're doing a little different. They're subtracting the 270 minus the 27, which is fine. That works. That's what's cool about ratio tables. Any strategy really works, and it's kind of open-ended for students how they want to figure these out. So Mr. Mack would have added the 8 plus the 1. This slideshow did the 10 minus the 1. So 10 minus 1 is 9. 8 plus 1 is 9. Whichever, they both work. So 270 minus 27 is 243. So when I look at my ratio, what they did, they subtracted 10 minus 1, but they're not just subtracting 1 on the bottom, they're subtracting the cost of 1 set of baseball, which is 27 here. So they're taking away 27, and you get 243. So 9 times 27 is 243. So how could we use the over strategy to find the cost of 99 sets of baseballs? So pause this, and I would like you to try this in your notebook. How could we find 99 sets of baseballs? We'll talk about this in class. And all right, I hope this helps. Next up, we're going to be talking about assignment number 1.